All right, you guys, in this section, we're going to be working with scientific standard notation as well as rational exponents, okay? So the first part of the lesson, we're going to distinguish between standard and scientific notation, okay? So you may be asking, well, what is standard notation? Well, standard notation is the way that we've always written our numbers, okay? So like if we wanted to write 5, we just wrote 5. If we wanted to write 1,000,000, we wrote a 1 and 6 zeros after it. Nothing special, nothing fancy, okay? But what scientific notation allows us to do, it allows us to write really, really, really small numbers or really, really, really large numbers in a more efficient manner, okay? So it's a lot easier to write 7.347 times 10 to the 22nd power than it is to write this, okay? So in order to write our answers in scientific notation, we have to know how to deal with them. So in this section, we're going to look at how to add, subtract, multiply, and divide, and simplify numbers that are written in scientific notation, as well as convert our numbers back and forth between scientific and standard notation. All right. So first, we're going to look at scientific notation. So in order to write a number in scientific notation, you have to understand what it needs to look like and how to move from one notation to the other. So a number is considered to be in scientific notation if it is expressed in the format n times 10 to the p power, okay? Now, to convert a number from standard to scientific notation, you're going to move the decimal point either to the left or to the right until the number n is between 1 and 10, okay? So this number n here has to be a number that falls between 1 and 10, okay? Step 2, the power or exponent is p. So this value here is going to be an exponent, okay? The sign of p is positive if the decimal point is moved to the left, and the sign of p is negative if the decimal point is moved to the right, okay? So when you're dealing with the exponent, it's important that you take note of which way you moved, because like it says, sign of p is going to be positive if you move to the left, sign of p is going to be negative if you move to the right, okay? And then step 3, the value of p is the number of times the decimal point is moved, okay? So I know now we're going through the steps. All of this will make a lot more sense once we do a problem, okay? So those are the steps that you're going to follow if you're moving from standard to scientific notation. If you are doing the reverse, if you're going from scientific to standard notation, all right, the step 1 is that you're going to move the decimal point. You're going to move the decimal point to the right if p is positive, and you're going to move the decimal to the left if p is negative. Okay, so remember, you can always back up the video to reference these steps. Also remember, you guys have my PowerPoint slides. So let's try to do an example. All right, so in this first set of examples, we're going to be converting from standard notation to scientific notation. All right, so the numbers both in A and B, they've given them to us in standard notation. We're going to convert them to scientific. All right, so let's change our pen color. All right, so this first number, okay? Remember, they said any number that's in scientific notation has to be in this form, n times 10 to the p power. And remember, n has to be a number that's in between 1 and 10, okay? So we have to keep that in mind. So right now, as we're looking at this number, we have 0.0000375. So we need to move the decimal in such a way that we create a number that's between 1 and 10. So if I look at this decimal point and I move it, I'm going to need to move the decimal to the right, okay? So we've gone 1, 2, 3, 4, 5, okay? If I stop there, then I get 3.75. So I have to ask myself, is 3.75 a number that's between 1 and 10? It is. So I can stop moving the decimal point at that point. So I'm going to have 3.75 times 10. Now I have to realize how many times did I move the decimal place? Well, I moved it 1, 2, 3, 4, 5 times. So P is your exponent. It's the many times that you move the decimal, okay? And we move the decimal to the right, okay? So remember, in our steps, okay, if we move the decimal to the right, then P is going to be negative, okay, from our steps. So I move the decimal 5 places and I moved it to the right, it's going to be negative. So that is our number written in scientific notation, okay? Now let's try B. Now for B, we have this large number, okay? Now something else you may recognize is that the number that's written in B doesn't have a decimal point. We don't actually see it, okay? So if you don't see a decimal point, it's understood to be all the way to the right-hand side of the number, okay? So even though it's not written, our decimal point is understood to be here. So once again, we need to move the decimal so that we create a number that falls between 1 and 10. So I'm going to take my decimal point and I'm going to move it. So I've got 1, 2, 3, 4, 5, 6, 7. All right, so when I moved it there, did I move it far enough? Well, the number has to be between 1 and 10. This would be 29.3. So that's still too big, which means that I have to move the decimal place one more. So that gives me 2.93. That works. So I have 2.93 times 10. Let's make that look a little better. Times 10 to the, how many places did we move? So I hope you guys are keeping track because I lost my spot. 1, 2, 3, 4, 5, 6, 7, 8. We moved it 8 places. And since we moved it to the left, our exponent is going to stay positive. Okay. So we've successfully completed both of those problems. We've converted them from standard to scientific notation. Okay. So let's check ourselves. Yep, we're correct. Those are our solutions. So the first one and the second one. Okay. Now let's try to do the reverse. Okay. So the reverse, before we were taking numbers that were in standard notation and we were converting them to scientific. Now let's see if we can take numbers that are written in scientific notation and convert them to standard notation. All right. So the first thing is for A, we have 1.25 times 10 to the fourth power. So I'm going to write that. I have 1.25. All right. And the exponent tells me how many times I'm going to move the zero, or the decimal point rather, okay? So let's go back up to our steps in case you guys forgot. All right, so we are in scientific notation. So if our exponent P is positive, we're going to move to the right. If P is negative, we're going to move to the left. All right. So let's write that for reference. So if we move to the right, that means P was positive. We're going to move to the left. P is negative. All right. Cool. So our exponent is positive, which means that when I take this decimal, I'm going to move it to the right 4 places. So I have 1, 2, 3, 4. Okay. When I move my decimal, I like to make these curves because inside of the curves, I'm going to place zeros. Okay. So my new number is equal to 12,500. Okay. All right, let's try B. So B has 7.6 times 10 to the negative third power. Well, our conversion measures tell us that if our exponent is negative, we're going to move the decimal to the left, and we're going to move it 3 places. So I'm going to have 1, 2, 3. I'm going to place the decimal there, fill in with zeros. So my new number is 0.0076. Okay. So that's how you convert numbers from scientific notation to standard, and then from standard to scientific. Cool.